Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with Chapter 3, which is solving equations. We're doing 3.6 today, which is the name of the lesson is solving decimal equations. Our essential question is, how do we solve equations with decimals? So, moral of the story for all math and life is don't panic, all right? So even though we're solving equations with, weird decimals and stuff in them, we're still going to follow the same steps of solving equations where we distribute, we combine like terms, then we move stuff around, okay? So we have a warm-up here to kind of illustrate how this kind of works. So why don't you guys go ahead and do the warm-up, pause the video, and give it a try. All right, sounds good. So for the warm-up, we have 2x equals 6. How do we solve for x? It's 2 times x, so to undo multiplying by 2, we need 2. Divide by 2. So x is going to equal 3. 6 divided by 2 is 3. Easy peasy. All right, number 2, 2x equals 6.6. This is a little bit weird, but it doesn't matter because we still do the same thing we would before. To get x by itself, to undo multiplying by 2, we got to divide by 2. So x is going to equal 3.3. And the last one is the trickiest one of them all, but not really because we're still multiplying this by 2.2, multiplying x by 2.2. So to undo multiplying by 2.2, we're going to divide by 2.2. So x is going to be equal to 3 when you multiply those out. Okay, so that was kind of illustrating the point that you don't panic. You do the same things you normally would. It's just going to be kind of weird numbers here and there, okay? All right, let's get into a rounding review. Label the following places of this number. See if you can write out this number and see if you can label each of these places. So, for example, the 1 is in the tens spot, okay? See if you can figure out the rest of them from memory, okay? Give it a try. All right, the 2 is the what? That is the ones place. The 9, that is the tenths place on the decimal. One spot right to the decimal. Then we have the 8, which is the hundredths. And we have the 7, which is thousandths. Okay? So that should be a review from middle school stuff. Those are kind of are important. It says, unless otherwise stated as a general rule for this class, we will round to the nearest hundredth for our answer. So we're going to round to the eighths. We're going to look at the 8, look to the right of it, and figure out what number we're going to have for that, okay? So what's the rule for rounding? What is the rule for rounding? Well, if you recall, there's a rhyme that I use for this, which is 5 or more raise the score, 4 or less let it rest. Okay, so if the thousandth place is going to be greater than or equal to 5 or more, we're going to raise the score around the hundredth place up. If the thousandth place is less than 5, 4 or less, we're going to let it rest or keep the hundredth place the same. Okay, so it's not too crazy. So we would round the above number to what? Well, we had 12.987, so we're rounding to the hundredths place. So if we're rounding to the hundredths place, we're going to look to the right of the hundredths place. And is 7, look at the 7, is 7 5 or more or 4 or less? It is 5 or more, so it means we're going to raise the score, we're going to round it up. So we're going to have 12.798, we're going to round to 12.99. And that's going to be our answer. If we had, for example, 12.983, we were rounding this one, we would, for this one, we would go, not equals, sorry. We would look at to the right of the 8, which is a 3, and that is 4 or less, we would let it rest. So it's going to be 12.98. You would keep the 8 the same, basically, okay? But the top one, that's kind of how you round. It's kind of a reminder from middle school math, all right? 5 or more raise the score, 4 or less let it rest. Look to the number to the right of the one you're trying to round to. If it's 5 or more, round it up. If it's 4 or less, you're going to let it keep the same. All right, let's get into some other stuff here. So this is back to the warm-up. The trick to solving equations with decimals is to not panic. Like I said, you follow the same steps to solve equations as before, but now with just wacky numbers. So it's choose your own adventure. You can try, a couple of different problems here, but we're going to try all of them together. So might as well just kind of get used to going through all of these. So we have negative 1.57p minus 4.85p equals negative 7.23. So the first step for solving equations is to look for distribution. Is there anything to distribute here, like a 2 like this or something? The answer is no, there's no distribution. Are there any like terms? There are like terms. There's negative 1.57p and negative 4.85p. Those are like terms. When we add the numbers in front, negative 1.57 minus 4.85, we are going to get negative 6.42p equals negative 7.23. Okay, we just add the numbers in front. Negative 1.57 minus 4.85 is negative 6.42. Any other like terms? Nope. Now we need to move stuff around, and we need to get p on one side and the constants on the other. Actually, p is alone on one side, which is good. The numbers on the other side, which is awesome. So now what's happening to the p right here when they're smushed together like this? It's actually going to be multiplication. So how do we undo multiplying by negative 6.42? We're going to divide by negative 6.42. Okay, so p is going to be, and then we're actually going to have to round here. When you divide negative 7.23 divided by 6.42, we're actually going to have we're going to have to round, so it's going to be an approximation. It's going to be approximately 1.13. Okay? I'm not sure if I rounded up or rounded down if I didn't write it on my notes, but if it's 5 or more, you're going to round this number up. So it's either if it's a 2 or 1 to a 3, or you're going to keep it the same. If it was a 3, it's going to stay a 3 if it's 4 or less. Okay, number 2, 1.08 equals negative 4.5r plus 5.1r. Okay, first things first, anything to distribute here? No. Any like terms? Yes, we got negative 4.5r and 5.1r. So we got 1.08 equals negative 4.5 plus 5.1 is 0.6r. How do we solve for, okay, no other like terms, that is. Now we got to solve for r. We need to get r by itself. It's kind of by itself, but we got that 0.6 there. How do we undo multiplying by 0.6? We need to divide by 0.6. So r is going to be, in this case, when we divide, we're going to get a nice number that goes to the 10th spot, which is 1.8. So we're going to put equals. One thing I should have mentioned, if you have to round, this symbol right here means approximately. If it's exact, it's going to be equal to. So when you divide 1.08 by 0.6, it's going to divide perfectly into 1.8, which is a decimal that ends, it terminates. Okay? See if you can try the last couple on your own. We'll go through those in a second. All right, number 3, 1.85 plus 1.9x equals x minus 2.2. Anything to distribute here? First step. No. Any like terms? Also no. Like terms have to be on the same side of the equal sign. We do not have any like terms. Now we need to get all the variables to one side. So you guys want to move the 1.9x or the 1x here? I probably move the 1x by subtracting x from both sides. There's nothing wrong with doing it the other way. That's totally fine, but I just like to keep it positive. I'm a positive person, so keep it positive, guys. 1.9x minus 1x is 0.9x. All right, now we need to get all the numbers to one side. We need to get rid of this 1.85. How do we do that? We need to subtract 1.85. So we get 0.9x equals negative 2.2 minus 1.85 is negative 4.05. Last step to solve for x, instead of multiplying by 0.9, we're going to divide by 0.9. So x is going to be, and this is going to be an exact answer, we're going to put equal to and not approximately, negative 4.5. If it ends, if it comes out to a nice decimal that doesn't go on forever, or doesn't go to the end of your calculator, it's probably an exact answer. All right, last example for this one, then we're going to do one more little example, and we'll be good to go. All right, number 4, 0.5m minus 7.9m equals 13.43 minus 5.7m. All right, do we have anything to distribute here? No. Any like terms? Yes, we got 0.5m and negative 7.9m, which is going to be, when we combine those, negative 7.4m, you just add or subtract the numbers in front. Equals 13, oops, that was bad, 3.43 minus 5.7m. Now we need to get all the m's to one side. How do you guys want to do that? You want to move the negative 7.4m or the negative 5.7m? That's a 7, actually. Let me fix that. Okay, here's the thing to be careful about that I saw people do sometimes. If we add 7.4m to both sides, let's just do that really quick. We're not actually going to do it. But you're going to have a 0 over here. You're going to have 0, and then you're going to have everything all on one side like this, which is kind of clunky. And you want to have a balance of things on both sides. Okay, so I would not add 7.4m here. What I would do is add 5.7m. And try to get everything on one side, but have equal things on both sides, basically. Because if you have things equal to 0, you're just going to have to move everything over there anyways, so might as well just kind of skip that step here. So when we add that, we're going to get negative 1.7 m equals 13. Just stuck with 3s today. 13.43. Last step to solve for m, we're multiplying by negative 1.7, so we're going to divide by negative 1.7. So m is going to be equal to, we're going to come up to a nice whole number, negative 7.9. I guess not a whole number, but it comes out to a decimal that terminates nicely at the 10th spot. All right, last example. Sometimes we can get rid of decimals altogether by multiplying by 10. So we have 4.5 minus 7.2x equals 3.4x minus negative 49.5. So instead of doing this, we can multiply both sides by 10, or any multiple of 10. You can do times 100, times 1,000. This is going to get rid of all the different decimals, that is. Because you're moving the decimal 1 to the right for all of these, right? Decimal's going to move 1 to the right, so we get 45 minus 72x equals 34x minus 495. All right, we need to get all the x's to one side now. What do you guys want to do? I'm going to add 72x to both sides here. Guess I should have asked if there's distribution or combining like terms. I skipped my steps, sorry. Bad, Mr. Prosky, not good. But there was no like terms or distribution to do here. So 45 equals 106x minus 495. Now we need to get all the numbers to one side, so I'm going to get 106x by itself by adding 495 to both sides. So we're going to get 540 equals 106x. Last step to solve for x is to divide by 106. And x is going to be approximately, because we have to round. If you round properly, you should get 5.10. Let me zoom out so you can see all these answers here. Okay, so that is our lesson for today for 3.6. Like I said, do not panic. Treat, you need to just solve these like you normally would. It's just going to be with weird numbers, and just stick to even if it feels uncomfortable, the way we grow is doing the next, right uncomfortable thing, okay? So don't panic, do your best, and thanks for watching, and have a great day, and we'll see you guys soon.